Hi, welcome to Dr. Raz, the Baking Chemist. So today's question is a Year 1 organic chemistry question. It's a 12-mark multi-part question with lots of different aspects of chemistry involved. Okay, so let's see what we can do. Isooctane is a common name for the branch chain hydrocarbons that burns smoothly in car engines. The skeletal formula of isooctane is shown below. Give the IUPAC name for isooctane. Okay, so IUPAC, International Union of Pure and Applied Chemistry, right? Not difficult, but needs practice. Okay. The other thing that needs practice is recognizing these skeletal structures, which I think students are finding it okay, actually. It's just, you need to do a bit of practice to get familiar with it, to the extent that you can actually do this under pressure, in exam environment. Yeah, so, okay, let's do this. So give the IUPAC name for the isooctane. Okay, so here we go. So it's, obviously, we need to find the longest chain. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I think it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right, so what you'll notice is that whichever way you count, the longest chain is 5 carbons. Okay, so what I'm going to do is I'm going to count that as my longest carbon chain, and then of course these are your prefixes. Okay, so let's do this. So it's obviously 5 carbon chain, so it's going to be a pentane. So I'm going to write down the root name, pentane, and then the prefixes. Now the prefixes is if I need to have the smallest numbers. If I count from this side, it's 1, 2, 3, 4. So it'll be 2, 4, and the 2 methyl groups will be on the second carbon. But if I count from this side, 1, 2, 3, 4, the 2 methyl groups will be on the 4th carbon. Now, which is right, which is wrong? Let me show you. Okay, so the first thing you got to realize is that all 3 of these are methyl groups. Yeah, so 1, 2, 3, all 3 of them are methyl groups. So it'll be a trimethyl. Okay, so trimethyl, and that means this trimethyl. So it's a trimethyl pentane. Now, looking at the numbers, if I say count from this side, 1, 2, so it'll be 2, 2, 2. So 2, 2, because there are 2 methyl groups. So 2, 2, 3, 4. So 2, 2, 4. So if I count from that side, it'll be 2, 2, 4 trimethyl pentane. But if I count from this side, it'll be 2, 3, 4, 4. So that means if I count from the other side, it'll be 2, 4, 4 trimethyl pentane. So the question is, which one's right? Well, remember, IUPAC's rules state that you need to give it the smallest numbers. Yeah. So obviously, if I count from that side, I'm getting 2, 2. So I'm getting 2 twice. Okay. So that gives me the smallest numbers. Okay. 2 twice and then 1's 4. Here, I'm getting 4's twice. Okay. So that's going to give you the largest numbers. So that's going to be wrong. So that will be the correct IUPAC name, 2,2,4 trimethyl pentane. While I'm at it, you probably won't lose marks for it. However, it's good. Yeah, remember, I always say to my students, you want to impress the examiners, right? You don't want to make them think, hold on a second, this guy or this girl, doesn't know her chemistry or their chemistry. Okay, so I'm going to start looking at every single thing in detail. They already do, but you don't want to give them that extra sort of reason, to doubt your chemistry knowledge. So what you should do is you should follow the convention. The convention is that between numbers, there are commas, so comma, comma, and between a number and a letter, there's a hyphen. If you put these, as I say, you probably won't lose marks if you miss out the commas or hyphen. However, it will make sure that the examiner is under no doubt you know your stuff. Okay, so it's 2,2,4 trimethyl pentane. Just 1 mark, so that's fine. Deduce the number of peaks in the carbon-13 NMR spectrum of isooctane. I have not done a video on NMR, carbon-13 NMR. Perhaps I think I probably will do it because it is one of the more sort of challenging topics, structure determination, the proton NMR and carbon-13 NMR. So perhaps I will do it. I've done one video where I've answered the question, where I've used actually the data, IR data and proton NMR to answer a question, and I'll probably put it over there, so you can have a look. But other than that, maybe I should do another sort of carbon-13 specific exam question. And by the way, I've also done an isooctane question, and that question is about the enthalpy of isooctane, okay, the heat energy, okay, and again, I'll put it up here, so have a look at it as well. Okay, so to deduce the number of peaks in the carbon-13 NMR spectrum of isooctane. Okay, so the first thing I need to look at is I need to look at the different environments of carbon, okay. Now, I'm going to start with that, and the way I do it, and I almost tell my students this as well, I ask them to label the environments with letters. So it's not numbers, yeah, because numbers you use for numbering carbons and all that, so, you know, let's not get confused, yeah, about that. So I just use letters. So that's the first carbon I've come across, so that's an environment. Here is a carbon, which is bonded to 2 other carbons, okay. That's not something that I've come across before, so that's a separate environment, B, okay. Now, this carbon is bonded to another carbon and another one here, so another carbon, so, and that one, but that's exactly the same as that carbon. Remember, this carbon was bonded to that carbon and that one. This carbon is bonded to that one and that one. So this and this looks like they're the same environment. Okay, both of them are bonded to a CH. All right, continuing on to the chain. So this carbon is now, I've not come across that where a carbon is bonded to all of that group and that group. Okay, so that's a separate environment. And then this one is a carbon. Now, I've not come across that where it's bonded to like 3 other methyl groups. So that's a different environment still. Okay. And then, of course, this, I've not come across that where a methyl group is bonded to sort of one carbon, which is bonded to 2 other methyl groups. Okay. So that's a methyl group bonded to only one methyl group. This methyl group is bonded to a carbon, which is bonded to 2 other methyl groups. So this is a separate environment. And of course, this is the same environment as that, which is the same environment as that. Okay, so that means all of these are E's because they're the same environment. So in total, I've got A, B, C, D, E. So in other words, the total answer is 5. Okay, so that's the answer.